All right, so for today, we're going to learn our last factoring method. So, for the most part, we know a lot of our different factoring methods. We have our normal method, which is just GCF. We could GCF anything out. Then, if we have a four-termed polynomial, we factor by grouping. If we have a trinomial, we can either factor it our normal trinomial method, or if it has a coefficient of a, we do the new method that we were talking about the past couple days. And now we're going to learn what to do when I have a binomial. So if I had, for example, something like x squared minus 25, how would I be able to factor that out? Well, whenever we look at a polynomial and we see a binomial, the only method for now, at least for this year, that we need in order to factor out a binomial is called the difference of squares. Now, to use the difference of squares, two things have to be true. First, the binomial has to follow the form a squared minus b squared. All right, and what that means is that the first term of the polynomial has to be a perfect square. And so does the second term. The first and the second terms both have to be perfect squares. Now, what I mean by perfect squares is that if I were to take the square root of the first term or the second term, I would get a number that is a perfect whole number. So, like the example that we have up here, x squared minus 25, x squared is a perfect square because if I take the square root of x squared, it's just x. Same with 25. If I were to take the square root of 25, it's just 5. Okay? An example of one that wouldn't work would be something like x to the third minus 16. 16 is a perfect square, or you can take the square root of 16 and get 4, but x to the third is not a perfect square. Okay, we can't take the square root of x to the third and get a perfect whole number. The square root of x to the third would be x square root of x. Okay, so this would not work. So this we can't do difference of squares with. We would not be able to factor this out using difference of squares. Okay? So seeing as that's the case, we're only going to focus on ones that are like this. Now the second thing we have to take notice of is the middle term, the sign here. The sign always has to be minus. Okay, it can't be plus. If you have a plus there, you can't factor it. Okay? Now just be careful. I could do something like this. I could kind of trick you here and go something like negative x squared plus 16. This I could factor because I could rewrite this as 16 minus x squared. So really what we're looking at is we want one of my terms to be negative. It doesn't matter if it's the first or the second, but one of the two terms has to be negative. Okay? They can't both be positive and they can't both be negative either. All right? Only one of them can be negative. So that's the second thing that we want to look for. So the first thing we're looking at is both terms have to be perfect squares. And the second thing we look at is the middle term, or one of the terms, has to be negative. Okay, so let's talk about how we would actually factor this out. So I'm going to use the example of x squared minus 25. So we'll just kind of put this off to the side here. And we're going to do x squared minus 25. So if I wanted to factor this, whenever I see a difference of squares, we're doing exactly what I was just saying to do. We want to find what is the square root of the first term. So the square root of x squared, if we remember back to what we were doing in chapter 10, which we were doing on virtual learning, the square root of x squared is x. Then we take the square root of the second term, the 25. All right, the square root of 25 is 5. So I have my x and I have my 5. So when I factor this out, okay, the factoring of a binomial that can be factored using the difference of squares. We take my first and my second terms after we take the square roots, and we put them, one of them, it's going to be x plus 5. So we'll take my two answers here. We'll take the x and the 5, and we'll add them together. And then in the other parenthesis, it'll be x minus 5. We'll take the two things again, but this time we'll subtract them. All right, so when we're factoring out a binomial using the difference of squares, take the square root of the first term, take the square root of the second term, take those two numbers, put them inside of your two parentheses. One, it'll just be the first plus the second, and then the other, it'll be the first minus the second. All right, so let's do a couple of example problems here. Seeing as this is a little bit of a shorter idea, or shorter lesson, I guess, we're going to be doing a couple more practice problems, and I'll have you do a couple more on your own as well. So let's say we wanted to factor out 16h squared minus 9a squared. Okay? Sorry about that. All right, so let's say we wanted to factor this. This is the problem we're given. We're told to factor it. So the first thing that we look at is, okay, can I use GCF? That needs to always be the first thing I look at. Is there a GCF between 16h squared and 9a squared? Well, we look at it, we look at the 16 and the 9, and we see that there's definitely not a GCF between those two terms. We look at the h and the a, definitely no GCF there, so I can't factor out a GCF. Then I look at how many terms there are. Obviously, if it's a 4-term polynomial, we would factor by grouping. If it's a 3-term polynomial, we would factor using our trinomial method. But in this case, this is a 2-term binomial, or a 2-term polynomial, or a binomial. So we're going to look to see if we can use the difference of squares. So, first thing we notice, minus in the middle, or one of the terms is negative. Good, so that is the first rule. Then I want to look at each term, and I say, okay, 16h squared. If I take the square root of 16h squared, will I get a perfect square? Will I get something that does not contain a square root? Well, if we remember back to simplifying our radical expressions, we would do this as the square root of 16 and the square root of h. The square root of 16 is 4. The square root of h squared is h. So I do get a perfect square. This is a perfect square trinomial, or sorry, a perfect square. Okay? I do the same thing with 9a squared. I want to take the square root of 9a squared. And I want to see, will this give me a perfect square? Well, I do the same thing as I did before. The square root of 9, that's going to be 3. The square root of a squared, that's a. So I see that both of them are perfect squares, so that means that I can use the difference of squares here. And all I do is I take these two terms, and I'm going to put them in my two parentheses. In the first parenthesis, it's going to be the first one plus the second one. And in the second parenthesis, it's going to be the first one minus the second one. And then that's going to be my answer. So my answer to the factoring of 16h squared minus 9a squared would be 4h plus 3a, 4h minus 3a. Okay, let's look at another one. Let's look at 121 minus 4b squared. Okay, so same concept here. We see that there is a minus in the middle, so this can be done by difference of squares. I should look to see, is there a GCF between 121 and 4b squared? There is not. So I work with this. I say it's a binomial. I'm going to factor it using difference of squares. So let's test if it works. We're going to take the square root of the first term, 121. 121 is a perfect square. The square root of 121 is 11. So the first one works. I'm going to take the square root of 4b squared. So again, I split it up. Take the square root of 4, that's 2. Take the square root of b squared, that's b. 4b squared is a perfect square. So because they're both perfect squares, I can just take them, take the first term and the second term, put them inside of my two parentheses. With the first one, you're adding them, and the second one, you're subtracting them. So my answer here would be 11 plus 2b, 11 minus 2b. All right, let's look at one more here. Let's move this down a little bit. Put it right there. Let's say we wanted to do 27g to the third minus 3g here. I'll put it in a different color as to not confuse us here. So what did I say? 27g to the third minus 3g. Okay, so here again, the first thing we should always look for is there a GCF between my terms? Now in this case, there is a GCF here. The 27 and 3, they have a GCF of 3. So I can pull a GCF of 3 out. The g to the third and the g, they have a GCF of g. I can pull a g out. So now I have to say, okay, 3g is the GCF between these. Now I'm going to take each of my terms divided by 3g and put what's left. So 27g to the third divided by 3g, that's going to give us 9g squared. Minus 3g divided by 3g, that's going to give me 1. Okay, now normally we would have stopped here. But now we have to look at what's left. Now we have to look at this 9g squared minus 1. All right, remember what I was talking about in the previous lesson. Whenever we take a GCF out, we kind of just forget about it for now and worry about it later on and just kind of bring it back in the end of the problem. We only worry about what's inside the parenthesis, and can I factor this again? Well, it's a binomial, so let's see if we could factor this using our new method here, using our difference of squares. So it is a minus in the middle, so that part works. I have to test, are my two terms perfect squares? So I'm going to take the square root of those two terms. So if I take the square root of 9g squared, all right, split it up. The square root of 9 is 3. The square root of g squared is g. So 9g squared is a perfect square. I'm now going to take the square root of 1. Well, the square root of 1 is just 1, so yes, that's also a perfect square. So because both terms are perfect squares, I can factor this again using my difference of squares, meaning take these two terms, put them inside of my two parentheses, where the first one, we are adding them, and the second one, we're subtracting them. But we can't forget about that GCF of 3g from the beginning. We have to bring that down into my final answer. So whenever you take a GCF out, like I said, forget about it for now, but bring it back down into the end of the problem. That 3g does not just go away, it's going to always be out front of the original, or of the final answer. Okay? So we have to realize that we cannot just end after doing a GCF. We have to look at what's left inside and see, can I factor that again? Okay, so I've put up 4 problems here on the whiteboard or blackboard here. Take 5 minutes, maybe a little longer if you've got 4 problems. Pause the video, and I would like you to try and do these on your own. Okay, just a little tip for that last one. You may want to rewrite that. Remember, we want that minus in the middle to make it a little bit easier for you. So you may want to rewrite that first. Okay, so hopefully these were the answers that we got here. We'll kind of go through these quickly. If we take a look at the first one, 81 minus c squared, no GCF. Square root of 81 is 9. Square root of c squared is c. So we take the 9 and the c, we put them plus and minus, and that's where we get our 9 plus c, 9 minus c. Same thing with the second one, no GCF. So I take the first one, take the square root of it, I get 8g. Take the square root of h squared, I get h. So I take the 8g plus h, and then the 8g minus h. Now for this one here, we see that we have a GCF of x. So I'm going to take an x out first, which leaves me with 9x squared minus 4. Now, with what's left inside, the 9x squared minus 4, I'm going to take the square root of 9x squared, which gives me 3x. I'm going to take the square root of 4, which gives me 2. So I'm going to take the 3x and the 2. It's going to be 3x plus 2, and then 3x minus 2. But I can't forget about the x on the outside here for the GCF. Okay, so now for this fourth one. I told you it may be a good idea to rewrite it first. All right, because we want that minus kind of to be in the middle. It just makes it a little bit easier for us to not really have to worry about the signs and everything. So we're just going to rewrite this so that the 9y comes first, and then it's minus 4y to the third. I do recognize that they have a y as a GCF, so I have to take the y out first. Then I divide everything by y, so I get 9 minus 4y squared. Take the square root of both of these, so the square root of 9 is 3. The square root of 4y squared is 2y. And then I take these and put it as 3 plus 2y and 3 minus 2y. But I can't forget about the y in front.